Okie dokie. So we are going to begin Unit 2, Lecture 3, which will be the final lecture for this unit before the test, and we will be addressing some of the ins and outs of how to calculate weighted average and how that applies to that little average you see on your periodic table. All right. So first of all, we need to understand what the difference between those two terms is. So we have an average versus a weighted average, and what looks different between those two. So before we begin, just so you can actually follow along and engage in what we're doing, you're going to need a periodic table and a calculator. You're going to need, so why don't you guys go ahead and hit pause and grab those things. And then of course you will be needing your notebook, etc. All right. So as we introduced in class, carbon has three major isotopes: carbon-12, carbon-13, and carbon-14. Now, if I find the average of 12, 13, and 14, right? Most of you guys can do the math quick enough to know that the average of those three numbers is 13. All right. Now, if I find carbon on my periodic table, which you all should have in front of you at this moment, I would find that carbon, right, so I find little symbol C, atomic number 6, and it has an average mass of 12.01. Okay, so we see, hopefully you guys are recognizing there's a difference between this mass right here, that average, and the average of 13. All right, so question is, why do we see that happen? Why do we get an average mass of 12.01 from the periodic table when clearly the average of 12, 13, and 14 is 13? All right, and what it comes down to is the values are different because not all isotopes of carbon have the same abundance. So when we talk about the word abundance, in this case, we're talking about how commonly we would find that particular isotope. All right. Now, so we could do some quick logic, right? Since the average mass of carbon is 12.01 AMU, okay, we should be able to guess that of those three, 12, 13, and 14, those three isotopes, 12 is by far the most common because this average comes out so close to 12. All right. So a weighted average then accounts for that fact. So if I had a handful of carbon atoms, right, the vast majority of them would be carbon-12 with a sprinkling of 13 and 14 mixed in. All right. So my average comes out a little above 12, but not super significantly so. And that's because 13 and 14, while they exist, are far, far less common than carbon-12. Okay. So weighted average accounts for the various isotopes and the relative abundance. How common is each isotope? All right. So here is the step-by-step, step 1, step 2, step 3 for how to calculate a weighted average. Step 1, identify the values you'll be averaging. So in the case of carbon, that would be 12, 13, and 14. Okay. 2, make sure you know their percent abundance, right? So in this case, what percent is carbon-12, what percent is 13, and what percent makes up carbon-14? 3, we're going to convert the percentages into decimal form, all right? Which just means we move, so let's say we had 78%, that would be 0.78, okay? So we just move the decimal 2 places to the left. All right. Then, number 4, multiply each value by its decimal abundance. So again, let's say, we'll put this in context in just a second. So whatever value we have, so 12, I'm going to multiply by its decimal version of its percent. So if 12 was 99.31% or something like that, I would go 12 times 0.9931. Okay? And then step 5 is add them up and then round using sig figs. Okay? So let's do this for carbon-12. See what this looks like. So carbon-12 has 98.93% of the atoms. Carbon-13 is 1.07%. And carbon-14 is pretty much negligible. It's less than 0.000001%. Okay? So when we say something is negligible, that means we're not really going to worry about it. Okay? So ultimately, the average mass is with the number of sig figs we have on our periodic table is a function of 12 and 13. We should notice if we add those two numbers, we actually get 100%. Of course, it'd be slightly less, but it'd be 99.99999%. Okay? So close enough to 100% for what we do. All right. So let's do this. So I want to know the weighted average of my 3 isotopes of carbon, where carbon-14 really is negligible. So step 1, if you recall, identify the values we'll be averaging. So it's going to be 12 and 13 in this case, not 14. Carbon-12 and carbon-13. Step 2, make sure I know the percent abundance, 98.93 and 1.07. Step 3, convert all percentages into decimal form. All right. So 98.93% is 0.9893, and carbon-13 is 0.0107. Okay? So those are my percentages in decimal form. All right? Then I'm going to multiply each value by its decimal abundance. So now I'm on step 4. So now I'm going to go carbon-12. So I'm going to go 12 times 0.9893 plus 13 times 0.0107. All right? I'm going to enter that on my calculator. And when I do that, I get 12.0107. Now, how many sig figs do I have in my number? So you might be wondering, should I count the 12 and the 13 as sig figs? And the correct answer there is no, because we're going to just call those exact numbers, right? So the numbers, for future reference, the isotope mass number will not count for sig figs. All right? Even though technically that's not super exact, we're going to go blanket statement. Isotope number, mass number, does not count for sig figs. So we're going to use the percentages to determine sig figs. Okay? Whoops. So if I want to round this, I need to round it to 4 sig figs. That would round to 12.01. And lo and behold, through some magic of numbers, we ended up with the same average mass for carbon as we see on the periodic table with the number of sig figs that we have available to us. Okay? So that's how we do it. So you guys are going to need to have this written down, right? So that on Wednesday we can grapple with this a little bit in class. Try to finish up that ChemQuest number 7. And again, it looks like test Friday. Okay, I'm not ready to put write that in stone just yet. It kind of depends on how things go Wednesday and Thursday. Maybe we'll push that back to Monday. Not sure how much that'll actually do for us, but probably Friday. There's a chance it'll be Monday. It just kind of depends on how things go. All right. So make sure you have these 4 or 5 steps written down, and that you kind of understand what they mean in context. So maybe combine your notes from this page with this, and do some annotating, so that when you're asked to do it for different elements, you are able to do so without too much of a headache. Okay. And if you need some help on Wednesday, I will be there, of course, to help you out.